Hello guys, if you're here, then I'm assuming you need help with circuits 1. So this series is gonna be covering these topics from circuits 1. So we have DC circuit analysis, which has all these topics. And today, for this video, we're going to be covering the circuit concepts of current, voltage, and power. And for the rest of the videos, if you wanna learn more about the rest of the topics, then I think I'm gonna make like more videos to cover those. So I just wanted to say that these notes are all by Dr. Naser Qaddoumi from the American University of Sharjah. He's the head of the department. So yeah, these are all his notes. They're very, very good. So let's start. So electric current. What is electric current? So electric current is basically the time rate of change of the charge. So when you have a specific charge which has units of coulomb, which is right here, and you measure how it's changing with respect to time, so which has units of seconds. So if you have dq over dt, that's basically current. That's all that current is. It's just a measure of how much charge is changing with respect to time. So the charge is a function of time, and how much is changing with respect to time is basically the current. So as you can see right here, you can infer that you can get back the charge by integrating this current with respect to time. So this is what you get. If you integrate the current with respect to time, then you will get back the charge. So yeah, this is basically the most important concept to gain from this topic. And of course, you need to know the units of the electric current, and it basically has the units of amperes, which is basically coulombs, which is the charge, the measure of charge per seconds. So yeah. So what else do we need to know about currents? We need to know the direction that the current is flowing in. So say you have a specific circuit like this. You have two nodes, A and B, and you want to know which direction the current is moving in, whether it's to the right or to the left. And yeah, it's all based on your reference. So you can have the positive to the right or the negative to the left, as you can see here. And you need to know the value of the current, of course. So these two parameters are important for studying currents. Also, you have two types of currents. One that is changing with time, and it's called AC current, alternating current. And they're usually in the form of sinusoids. Or direct current. Direct currents are basically constant currents that don't change with time. So here you're gonna have are basically graphical representations. So this is what an alternating current looks like. As you can see, in each value of time, you have a specific value of the current. So it's changing with time. And in this case, it's a sinusoid, as you can see. Whereas DC current, it just remains constant. So as you can see, it does not change with time. So examples of DC current are automobile batteries or flashlight batteries. So basically currents that stay the same, and they usually don't require power sources, because power sources like from your outlets are alternating currents. So these include things like household equipment and washing machines, etc. So let's take an example. So this example says, if the total charge entering an element is given by this, so you have a charge that is a function of time. As you can see, the variable here is time. So this is a representation of a specific charge with respect to time. So the question asks you to find the current at the time t equals 0 and t equals 3. So first of all, we need to find the equation of the current. And what did we say the current was? It's basically the change of charge with respect to time, right? So current with respect to time is the measure of charge with respect to time. So all you have to do in this case, since we have an equation of the charge with respect to time, we just have to derive it with respect to time and you will get the answer. So that's exactly what they did here. They derived the charge with respect to time. I'm sure you guys can derive this simple equation, right? So let's just do it for the sake of doing it. So d of 6t squared minus 12t, this entire function, derive it with respect to time. What do you get? So if you derive this part, you'll get 12t, and this part you'll get 12. So yeah, this is the function of charge with respect to time. And if you want it at a specific instant of time, you just substitute the t for those instances and you will get the answers. And of course, don't forget the units. So the units here were millicoulombs. So the units you get here are milliamperes. And again, milliamperes is the same as milli-what? Charge per time, right? So coulombs per seconds. So you can say this as well for the units. Just remember what the amperes stand for. So moving on. Forgot my notes over here, so yeah. So now we're gonna talk about voltage, energy, and power. So these are very, very important points. Like, yeah, this is basically what electrical engineering is all about. So let's start. What is voltage? So voltage is the potential related to the energy change. So voltage is basically the work that is required to move a specific charge from a specific point to another. So it's basically the work done on the charge with respect to the charge. So you divide it by the charge. So if you have a specific work, U, and a work has the units of joules, remember? And you know the specific charge value that this work is being done on. If you divide these two units, you will get the value of the volts, which is basically the potential of the energy. So if you think about it intuitively, what does it mean? What does it mean if you have a specific voltage? It basically means that it describes like the potential that the specific charge will have, if you get what I mean. Like, how much energy does this charge have? Like, how much potential does it have? And if you want to get the work done, you will just multiply it by the amount of charge you have, and you'll get the work done by that charge. So if you have a specific volt, say 3 volts, and you know that you have 3 coulombs of charge that this work is being done on. So if you want to know the energy or the work that has been done on this charge, you just multiply the volts by the charge. Because the units of volts are joules per coulomb, and the unit here is coulomb, these will cancel and you'll get back the unit of joules. 3 times 3 is 9, so you'll know that the work done on this charge is 9 joules. This is just an example. So yeah, this is basically what the unit of voltage means. The change in voltage is basically the energy done, the work done on the charge divided by the charge. So the charge is randomly moved. However, if we want the charge to move in a certain direction, we must apply an external force or an electromotive force. Thus, there will be some work done on the charges. So if charge dq gives up energy, dw, when going from point A to point B, then the voltage across those points is defined by, so if you have 2 nodes, for example here you have a circuit and you have 2 nodes A and B. So if you want to know what the work done to move a charge from this point to this point, and you have the specific charge like that is moving, all you have to do is find the rate of change of the units of energy, dW, and find it with respect to the change in charge, which is in units of Coulomb. And that's how you find the voltage from two nodes A to B. So again, the units of the dW, which is work, is in joules, and dQ is in Coulomb, and voltage from A to B is measured in volts. So let's look at examples. Well, there aren't examples, so what can we extend on this? So say, for example, the difference in the voltage in these two nodes is 2 volts. And as you can see, there's a polarity associated with this. So the node A has a higher potential than node B, which is denoted by the negative. So what does this mean? Again, we noted how the current has a direction, right? So does the voltage, it has a polarity. So what does it mean? It basically means that moving a unit of charge from A to B, so we're going from higher potential to lower potential, it basically means that the charge will give up 2 joules. So again, because we have 2 volts and we have 1 coulomb of charge, we'll just multiply them. So 1 times 2 is 2, and you get back the unit of energy. So the charge will give up, it basically means that the charge will give up 2 joules of energy if it moves from point A to point B, because point A has a higher potential than point B. Whereas if you're going in the opposite direction, if the charge is moving from point A to from point B to point A, so it's going from a lower potential to a higher potential. What does that mean intuitively? It means that the circuit would have to supply that amount of energy, which is, again, we just found it, it's 2 joules. The circuit would have to apply or supply that amount of energy to move the charge from point B to point A, because again, it's moving to a higher potential. So I guess that explains it, hopefully. I hope you guys understand what voltage is. Again, let's just recap. So the voltage is related to the energy that is required, or the work done on a specific charge divided by that charge. And then finally, we have power. We all love power, don't we? Okay, that was lame. Anyway, so this is very important. You guys have to know what power is. So what does instantaneous power mean? Instantaneous power is defined as the rate of doing work or the rate of change of energy. So if you have energy and it's changing with respect to time, then you have power. That's basically what it means. So and you can find the power, the instantaneous power, by multiplying the voltage by the current. So this is very important to know. And why does this hold true? Let's look at this further. So if you want to know the power, it's the voltage multiplied by the current. Let's look at we know that power is a unit of energy per time, right? So it would have to be joules per second. Those are the units of power, right? So let's look at the units of the voltage and the current individually. So the unit of voltage is work per coulomb, work per charge, right? And what is the units of current? The units of currents are current per time, seconds. So as you can see by dimensional analysis, these two terms cross out. So you have work, which is, sorry, this is supposed to be joules. I don't know what I'm thinking. So yeah, the unit of work is joules, right? So you'll get back the joules per second. Let me just write that in a better way. So you get joules per second, which is what we expect from power. So again, so because it's the change of work per time, you can always get the work back by integrating the power with respect to time. So this is what we have here. If you integrate the power with respect to time, you will get back the work done in a specific time frame from 0 to t time. So let's just cover the measuring devices. So in electric circuits or just electrical engineering, these are obviously very important. So the devices that measures current are called ammeters. The devices that measure voltage are voltmeters, and the watt meter measures the power. So you guys will get more into that later. So guys, we've come to an end to this video. I hope you found this introductory video to electric circuits very useful. If you want to see how I solved this problem on power, then check out my next video. But yes, all in all, I hope you found this video very informative and helpful, and I wish you the best of luck in all your studies.